QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Consider 2x squared plus 7x minus 1 equals 0. Is this quadratic trinomial on the left-hand side factorable? Yes or no? The answer is no. Next question. What should be the constant to be added on both sides for the completing the square process? And the answer is 49/16. With this information, what are now the roots of the given quadratic equation? And the roots are positive and negative square root of 57 minus 7 all over 4. Did you get 3/3? If not, please continue viewing this video. To solve for the roots of this given quadratic equation, we need to understand the correct process needed for the said unknown. We are going to decide which process we're going to use. Of course, we have a quadratic formula for that, but for here, let's just use other method in order for us to practice as well important concepts in mathematics. Now, we could decide the method by identifying the coefficients. You have here 2, your coefficient here for B is 7, and your C is -1. Now, since this is a complete quadratic trinomial, this would mean that we cannot use the extracting over square roots, and we cannot also use here the common minimal factoring. But we need to examine whether this can still be factored as a trinomial or not. Then if it's not, we will move to completing the square method. We can do that by identifying the AC. AC here is 2 times -1, and AC is -2. If we could look or find factors for -2 that when added will result to our B coefficient 7, then in short this is factorable. If it's not, then we need to move for completing the square method. So the factors here are 1 and -2, and you could also try -1 and 2. Both of these pairs of factors when multiplied will result to AC, but none of them when added will result to +7. This is a proof that this trinomial is non-factorable, and hence we are going to use the completing the square method. This method actually will allow us later on to factor the said trinomial and even use extracting square roots by looking at the correct or finding the correct constant to be identified. Here, our constant is -1, but it's not what we need in order for us to factor the entire trinomial. Hence, we are going to look for another value. So this again, 2x squared plus 7x minus 1 equal to 0. Let's move 1 here. So you will have a binomial expression 2x squared plus 7x is equal to 1. Then we are going to look for an appropriate value of C here in order for us to factor this. And just a heads up, whenever we use completing the square method, we will be expecting radical expressions. This is why, again, I'm a firm believer that we should start with the radical expressions before the quadratic topics, because we need to understand first how radical expressions work in order for us to finalize the result here. But at the same time, since we cannot, there would be a complicated process later, let's try to divide all terms here by 2, making our a coefficient, the new a coefficient, not the original, would be 1. And this would become 7 halves x. This is equal to 1/2. And let's look at the new c. The new c coefficient, let's label it c sub 1 so that not to be confused with the original c, is actually computed as b over 2 times the square root of a, and then you raise it or you square it. Now, this b and a here are not the original values of b and a, but for this new here. So if you could also use label here sub 1 just like that. And sometimes this formula will no longer use square root of a, since we are sure this is 1 and square root of 1 is just 1. But just for the purpose of the entire formula, I'm presenting it like that. But here comes the process, and this might be a little bit confusing for some, but so let me try to discuss this like this. B is 7 halves, and we will divide it into 2. And square root of a is square root of 1, and then you square it. Take note that you are dividing a fraction by a integer, or also a fraction in terms of 2 over 1. So you could have this process here. You'll have 7 over 2, and take the reciprocal of the denominator and make it multiply 1 times 2. Okay, you might want to review your methods on fractions here. So you will have 7 over 4, and you square that. The constant that you need, this is a process that you also need to review, okay? The constant that we need is not 1 as noted earlier, nor 1/2 here. It's 49 over 16. That's the value we're going to add here. So you'll have x squared plus 7 halves x and plus 49 over 16. And with this is already a perfect square trinomial, and hence we can factor it later. But don't forget to do the same thing on the other side. You will have 1/2 plus 49 over 16. So this is now a perfect square trinomial as mentioned. So you could have this binomial here. You have x, a square root of the first term. Square root of the third term is 7/4. And use the sign of the middle term to get your square of a binomial. And this is equal to the result of this. Using the LCD of 16, we know 1/2 as 8 over 16. So 8 plus 49 is 57 over 16. And from here, we can use the square roots method so that this square here will be removed. But don't forget the plus minus notations here. So you have x plus 7/4 is equal to plus minus square root of 57 all over, I am separating them immediately, square root of 16. Since 16 can be still simplified. Pardon with this step here. Let me separate this one here. Let me do it again. Okay, so there will be no confusion. So you'll have x plus 7/4 is equal to plus minus square root of 57 here, and square root of 16 is an integer 4. To finish, we will subtract both sides by 7/4, so you will have your roots as plus minus square root of 57 over 4, then minus 7/4. You can still combine that, and then you will have these two solutions. Your first solution is the positive square root of 57, that's 57, minus 7. Since they are similar fractions, you can combine them into 1, just like this. And then you will have the second root, which is the negative version of the square root of 57, still minus 7 all over 4. See, you have radical expressions here, so please review radical expressions before quadratic expressions or even quadratic equations like this. And this is the process of solving that. It might be long, too long, but this is what we need. And of course, this will be verified using quadratic formula, but for the use of completing the square, this is the discussion of the answer for this QuadQuiz. Subscribe now.